Welcome to day 13. Before you start today's video, take a quick look at the link in the textbook on phasing metronomes. This is going to give you an idea of why intonation is so important, because your strings actually sync up with each other very, very quickly. Now let's open this giant can of worms that we call intonation. First of all, every single pitch is a compromise. So we're going to start with something called the Sevcik paradox. If you play a B on your A string, and you make it perfectly in tune with your E string, you're going to notice it doesn't match your D string. It doesn't match at all. So I have to actually make it a little lower. Ah, that sounds so much better. But it doesn't match the E string. Ew, gross. Okay, so we have a problem there. We have to figure out how to make every single pitch go with the chord that we're playing. This is why intonation becomes so difficult, and there's so many different opinions on it. So I want to introduce to you a little bit of the idea of inharmonicity and also of pure thirds and pure sixths. You're probably used to perfect octaves, perfect unisons, perfect fourths, and perfect fifths. Those are a little less negotiable, but pure thirds and pure sixths also allow sixths and thirds to be in ratio with each other. So I'm going to go ahead and play a major third, and ironically the major third is a good deal smaller than you might expect. Listen to the tartini tone. You can hear that third pitch? That's the difference between the two pitches. I'm now going to play the opposite of a major third, which is a minor sixth. And this one, instead of being a little smaller than you might expect, is going to be a little wider than you might expect. And if you're listening closely, you can also hear the tartini tone on that one. Then there's the minor third. The minor third, contrary to popular opinion and equal temperament, is slightly larger than you might expect. And here's where we discover that an absolutely pure minor third on a modern instrument is not entirely possible because of something called inharmonicity. I'll leave that more to the textbook, but let's listen again to it as pure of a minor third as we can manage. And then a major sixth, which is smaller than you might expect. This is one of the ways of looking at chords, but then we have another problem, which is chromatic pitches. And it was suggested by Leopold Mozart that these could be made up of 9 parts to the whole step, which means they would alternate 4- and 5-part half steps. Let me demonstrate what I mean. I'm going to start with a 5-part half step and then a 4-part half step. They will add up to a 9-part whole step, and we'll just go up a few notes. So starting with a 5-part half step. And now a 4-part. And now alternating 5- and 4-part. You might notice that that's not quite what you're used to with a chromatic scale. It's actually built into code in most of Mozart's, Haydn's, and Beethoven's scores, that if it's a sharp, you're going to play it on the low side. And if it's a flat, you're actually going to play it on the high side. And this has to do with the 4- and 5-part half step concept. So first train the ear, and then train your fingers to adjust quickly. There's an exercise in the text today using a scale with vibrato and multiple drones. So you'll take a G major scale and you'll tune all the perfect intervals with a G drone. Then you'll put it on an A drone and still play the G major scale, tuning it with the drones. And then finally a B drone, same idea. Once you've trained yourself to adjust quickly, you can use melodic, just, or equal temperament intonation at your pleasure. Excellent playing requires constant, quick adjustment.